Hello, welcome to Astronautics for Exploit. This is Dr. Ayeshola Ogundele. Imagine and next generation lunar power technologies and concepts. The focus points of my presentation are as follows: lunar power and imagine and next generation lunar power technologies and concepts. For many years, several government space agencies, private space companies, universities, and interested public individuals have been planning and developing different proposals of manned bases, villages, and cities for living and working on the lunar surface. The idea, which started as a science fiction, is gradually becoming a reality based on increasing investment in various emerging and next generation lunar power technologies and concepts. Through unmanned robotic exploration of the moon, various factors that are necessary for the successful construction of moon bases and villages are identified as electrical power, water, livable region on the moon, temperature, moon terrain, and shaded area from radiation. The renewed interest in manned moon missions is necessitating the need to have further lunar infrastructure in place. Research findings show that for successful manned moon missions, there is the need for reliable, sustainable, and available electrical power system for life support, rovers, vehicles, scientific equipment and laboratories, research and development, in-situ resource manufacturing, and a host of others. Some of the various proposed concepts of emerging and next generation lunar power technologies and concepts of lunar power generation, distribution, and transmission are as follows: lunar crawler, vertical solar array technology, lunar microgrid for future lunar base, lunar nuclear power system concept, light bender, laser power beaming to the moon technology, and a host of others. Researchers have shown that vertical solar array technology is a promising technology that will be better than horizontal solar panels. Different design and prototype development of autonomously deployable lunar vertical solar array proposals for future lunar South Pole exploration missions are being put forward for consideration. This is aimed at demonstrating viable solutions for reliable power sources on the moon, which are key to the success of these missions. Lunar power. In the future, humans are proposing to live and work on the moon for weeks or months or years. Energy and power will make it possible to travel to and live on the lunar surface. In order to make power available at all time on the moon, several emerging and next generation technologies are being proposed. The picture here shows astrobotic lunar grid concept. Emerging and next generation lunar power technologies and concepts. The various emerging and next generation lunar power technology and concepts are lunar crawler, vertical solar array technology, lunar microgrid for future lunar base, lunar power grid, light bender, moonbeam technology, silicon carbide power technology, modular DC energy reactor technology, lunar nuclear power system concept, and laser power beaming to the moon technology. Lunar crawler. Lunar crawler is being proposed to be used for the fabrication of lunar solar cells on the surface of the moon. The crawler is designed to traverse lunar surface, smooth, melt a top layer of regolith, then deposit elements of silicon PV cells directly on the lunar surface. The picture here shows lunar solar crawler concept. The components of Moon PV array production system are raw materials production system, PV cell emplacement crawler, utility subsystem that transports raw materials from the materials production to the cell emplacement subsystem, connection of the PV's power system, power distribution, maintenance, and repair of the solar array system. The picture here shows the picture of crawler. Lunar silicon solar cells fabrication. The fabrication of the lunar silicon solar cells will be accomplished by a movable crawler traversing the surface of the moon and depositing the solar cells on the regolith. The regolith will be melted for a glassy substrate for the cells, and the solar cell layers will be sequentially evaporated into the regolith substrate. The picture here shows artist's impression of a lunar base. Moon equatorial region. The crawler is aimed to initially be used in equatorial regions of the moon with an east-west motion to minimize the need for complicated tracking of the sun by the parabolic truth collectors. Only 1 degree of rotation freedom will be needed to track the sun. The crawler will support a plow in front to smooth the regolith and move larger rocks. It will also have a solar panel to support the communication, command and control, and motive functions of the crawler. The picture here shows inflatable module concept for lunar base. Vertical solar array technology is another technology demonstration for the lunar base. Vertically deployable solar array concept is one of the most advanced concepts. Existing space solar array structures and deployment systems are designed for use in microgravity or horizontal surface deployment. The vertical position and height of this new concept are intended to maximize the capacity and prevent losses at the lunar pole, where the sun does not rise very far above the horizon. The picture here shows vertical solar array. Various companies are working on the concept of vertically deployable solar array concept, and some of them are Astrobotic Technology, Northrop Grumman, Honeybee Robotics, Lockheed Martin, and Space System Lunar. The design targets are to remain stable on steep terrain, be resistant to abrasive lunar dust, and minimize both mass and packet volume to aid in delivery to the lunar surface. The designs of solar arrays that can autonomously deploy up to 9.5 meters high and retract for relocation if necessary are ongoing. The picture here shows Lockheed Martin vertical solar array concept. Prototype concept. The companies are building vertical solar array prototypes and performing environmental testing with the goal of deploying one of the systems near the moon South Pole in the nearest future. The solar panels will not be spread on the ground or some flat surface, as they generally do on Earth, but will be vertical and must be high enough to prevent loss of power due to the moon's terrain blocking the sun. The picture here shows illustration of vertical solar panels on the moon. Lunar power grid is another proposed concept. Lunar grid is a power generation and distribution service that will deliver power by the wire to landers, rovers, habitats, science shoots, and other lunar service systems. Astrobotics Lunar Grid will use vertical solar arrays and rovers to deliver power to customers at the south pole of the moon. The picture here shows Astrobotics Lunar Grid. Lunar Grid will combine solar arrays with tethered rovers that will deliver uninterrupted power to customers on the lunar surface. The power will be generated by vertical solar array technology. Solar arrays that are deployed vertically and are optimized for operations are the lunar poles, where the sun is always low on the horizon. The picture here shows illustration of lunar grid on the moon. Lunar microgrid for future lunar base. Companies such as Sandia National Laboratories are working to develop a reliable and resilient microgrid for the moon. The mining and processing facility on the moon could produce rocket fuel, water, oxygen, and other materials needed for extended exploration of the lunar surface, while decreasing supply needs from Earth. The picture here shows microgrid concept developed to power the moon base. The mining and processing facility on the moon is designed to have one microgrid and an electrical system controller, while the habitation unit is designed to have one microgrid and an electrical system controller. The facilities are planned to be located far away from the moon base camp so as to prevent disruption of science and technology activities. The picture here shows Viper rover atop of the astrobotic-driven lunar lander to be delivered to the south polar region of the moon in late 2023. Lightbender is another proposed concept. Lightbender is another novel concept under development for a lunar south pole based deployment, which utilizes a combination of mirrors and lenses to capture, concentrate, and focus the sun's light. The sun's light is collimated by a Fresnel lens for distribution to multiple end users at distances of a kilometer or more away, where it is converted to electricity using small PV arrays that can be mounted on orbiters or assets such as mobile rovers. The picture here shows light bender concept. The light bender concept is considered superior to alternatives such as laser power beaming, as it only converts light to electricity once, and which is approximately 5 times mass reduction to traditional power distribution architectures that rely on mass-intensive cables. Advantage of this concept is that it enables the powering of scientific and other assets in permanently shaded areas. The picture here shows illustration of a proposed industrial base for mining water and producing propellant at the lunar pole. Moonbeam technology. Moonbeam technology is developing a compact and modular directed energy system for wireless power transfer utilizing near-infrared laser light. Potential applications of this concept include exploration and resource utilization in the permanently shaded regions of the moon with multiple rovers at ranges beyond 1 kilometer. The picture here shows vision of an international research base on the moon. Silicon carbide power technology. This technology is aimed at delivering silicon carbide power components that are radiation tolerant and can operate near the rated voltages without the radiation-induced burnout or degradation to which they are susceptible in the space environment. Due to their low losses and high voltage and current ratings, this concept of power dams and transistors are otherwise ideal for space applications. The picture here shows a moon-based concept of the demonstration of remote construction. Modular DC energy router technology. The goal is to develop a modular DC energy router that can function not only as a power flow controller, but also as an intelligent circuit breaker. Some of the applications emphasized with these technologies include drilling for water, oxygen extraction, and analysis of the strength and composition of the lunar surface strata, all of which will support a growing presence on the moon increasingly reliant on the local resources. The picture here shows a lunar-based concept proposal. Lunar nuclear reactor system concept. Various efforts are ongoing to advance space nuclear technologies. Different concept proposals for a fission service power system design are being planned for a demonstration on the moon in the future. Relatively small and lightweight compared to other power systems, fission systems are reliable and could enable continuous power regardless of location, available sunlight, and other natural environmental conditions. The picture here shows illustration of a conceptual fission service power system on the moon. Laser power beaming to the moon technology. Laser power beaming is being considered to charge up rovers on the moon for mining water on Mars. According to the research findings, laser power beaming could provide a source of power to robotic systems in permanently sighted regions of power landers and rovers from orbiting spacecraft. The picture here shows illustration of the laser power beaming at the Lunar Reconnaissance Orbiter. For more information, contact Astronautics for Exploit. You've been watching and listening to Imagine Our Next Generation Lunar Power Technologies and Concepts, presented by Dr. Anyashola Ogudele, Astronautics for Exploit, with the focus points lunar power and emerging and next generation lunar power technology concepts. Thank you.